Radian and degree measure. This is an introduction to the work we'll be doing on trigonometric functions. So let's start by reviewing the degrees in a circle. We know that there's 360 degrees in a circle. If we call 0 degrees the place at the east, if you will, it's also 360 degrees because it's a full revolution. Then half of the way across the circle, the place at the west would be 180 degrees, north would be 90 degrees, and south would be 270 degrees. So we could cut each of these quadrants in half, and this would be 45 degree increments. So 45 degrees is we call it the northeast. And then in between 90 and 180, we have 135 degrees. We get that by either adding 45 to 90 or subtracting 45 from 180. Now if we add 45 to 180, we get 225 degrees. Let's add 45 to 270 and we get 315 degrees. So we can think of these as our 45 degree family. Now what if we took a half a circle, that is from 0 to 180, and we divided it into 6 equal parts? Then these would be 30 degree increments. So that's 30, and then here we have 60, and then of course 90, and then 120, 150, and then 180 is part of that, 210, 240, 270, 300, 330, and then our 360 degrees. So these are very popular degree measures for angles that we'll be thinking about in this unit. Now we want to have a new way of measuring angles. We want to think of something called radians. And a radian it's a measurement, and one radian has a specific angle measure. And we want to really delve into what is a radian. And so this little animation will help us understand radians. We start with a circle of radius r. Now we take that radius, and imagine if it were a piece of string, you could lay it on the circle, right on the circumference like that. And now an angle has been formed. The measure of that angle we're going to call 1 radian. And we can find 2 radians, 3 radians, and all the way across the circle is a little bit more than 3 radians. It's exactly pi radians, because pi, you remember, is about 3.14. 2 pi radians is all the way across, all the way around a circle. So what we're going to remember in this unit, when we think about radians, we're going to think this is a way to measure angles. And remember, 1 radian has a specific angle measurement. It's the angle that's formed from laying the radius of the circle along the circumference. That's a radian. I really want you to remember that pi radians is exactly equal to 180 degrees. That's going to be a conversion factor that will be very useful. And 2 pi radians is exactly equal to 360 degrees. So now what about pieces of like a part of a radian or a fraction of a radian? So this particular circle looks very daunting, doesn't it? We remember that pi radians is 180 degrees and 2 pi is 360, but where do all those other fractional radians come from? You know, in math we want it to make sense. We don't want to just memorize things without really attaching any meaning to it. So let's try to make sense of these fractional radian parts. So here we have our circle. We know that, again, just like 0 degrees was on the east, 0 radians will be on the east. 180 degrees was on the left. That will be pi radians. Therefore, pi over 2 is up at the north, and 3 pi over 2 is in the south there. So we would love for you to just be very familiar with the pi over 2 family of radians, starting at the 0 radian spot, then going Counterclockwise, we get pi over 2 radians, then pi, then 3 pi over 2. All right, now what if we divided each of these in half again? This is now our pi over 4 family. So starting at 0 radians, let's go right around the circle. And we're conveniently not going to simplify the fractions so that you can understand these are all part of the pi over 4 radian family. We have pi over 4, which also equals 45 degrees, but let's just try to think about radians here. Then we have 2 pi over 4, 3 pi over 4, 4 pi over 4 is the same thing as pi radians, 5 pi over 4, 6 pi over 4, 7 pi over 4, and back at the starting point, it's 2 pi or 8 pi over 4 radians. So that's what our pi over 4 family looks like. Now what we might consider is if we took pi radians and we divided that into 6 equal parts, then this would be our pi over 6 family. So let's take a look at 0, which is on the east, if you will, spot. And then let's go right around the circle counterclockwise. We have pi over 6 radians, 2 pi over 6, 3 pi over 6, which you know is the same thing as pi over 2. But we're writing it in terms of pi over 6 just for consistency. And so this is the location of all of the pi over 6 radian angles. Finally, what if we started with our pi radians and divided it into thirds? Then this would be our pi over 3 degree family. So again, starting at 0, going counterclockwise, pi over 3, 2 pi over 3, 3 pi over 3 is another name for pi, 4 pi over 3, 5 pi over 3, or 6 pi over 3, which also equals 2 pi.